So section 2.2 introduces two new derivative rules, and it's kind of continuation of section 2.1. I imagine I'll do this section in two videos as opposed to one, so let me just get started. The two rules that we're going to learn are the product rule and the quotient rule for finding derivatives of functions. The product rule is a rule that's used to take derivatives when there's multiplication, and the quotient rule is used to find derivatives when there's division. In section 2.1, we learned how to take derivatives of functions when there's multiplication by clearing the multiplication. In this section, we'll find out that we can find the derivative without clearing the multiplication if we use the product rule. And it's kind of a bad thing because now we're going to have two different techniques that might work to take the derivative of a single problem, and it's usually best if there's only one strategy that works to find an answer. But problems like number 1 and number 2 on this sheet, I could find the derivative like I did in section 2.1. Specifically, I could FOIL and then take the derivative of each term and avoid the rule that we're going to learn in this section. Or we could learn the rule that we're going to use in this section. So there's at least two ways to find the derivative of problems 1 and 2. Let me teach the new way and then show you how we might have done it in section 2.1. So if there's multiplication and both factors have an x, we can use the product rule to find a derivative. The product rule basically says if there's multiplication, and both factors, or both terms, I'll call them factors, have an x, the derivative, I'll start on the right then, the derivative can be found by using this rule. And I'll write it in words as opposed to symbols. So if I said a function equals the first factor times the second factor, then the derivative, that's a little prime symbol, equals the first factor times the derivative of the second factor plus the second factor, running out of room here, times the derivative of the first factor. So in terms of the problem number 2 that I should probably start doing, if I look at problem 2, it's not written in function notation, but that's not the crucial deal. So I have a problem that has multiplication, y equals to 3x minus 4 times, there's the multiplication, 5x minus 8. There's multiplication, and for this particular problem, I'm going to say the first factor is 3x minus 4. The second factor, the second thing that's being multiplied, is 5x minus 8. So if I look at the little sentence fragment that I wrote, I said if there's multiplication, and here there's multiplication, 3x minus 4 is multiplied by 5x minus 8, and both factors have an x, the letter in the problem could be y or z or w. If both factors have a variable or a letter, the derivative can be found using this rule. So there's multiplication, both factors have an x, so the derivative can be found using the product rule. In order to use the product rule, I need to know what each of the factors are, and I need to know the derivative of each factor. So before I find this derivative using the product rule, derivative of the first factor, I'm going to write down what the derivative of the first factor is and the derivative of the second factor, because I need those pieces to find the derivative. So in order to use the product rule, you need multiplication. You don't need function notation, but both factors have to have a variable or a letter. And the product rule has 4 pieces. First factor, which I have, is 3x minus 4. Derivative of the second factor I need to figure out, plus second factor I have, 5x minus 8, times the derivative of the first factor, which I need to figure out. Super easy to find the derivatives. The derivative of the first factor is just the derivative of 3x minus 4, and that's super easy derivative to take. The derivative of 3x, because it's a first power term, is just the number in front of the x, which is the 3. The second term, because it's a number without a letter, has a derivative of 0. So the derivative of 3x minus 4 is just 3. The second factor, 5x minus 8, I need to find its derivative. The first piece is a number times a letter to the first power, and the derivative of a number times a letter to the first power is just the number in front of the x without the x. The derivative of 5x is just 5. And the second piece, minus 8, because it doesn't have a letter, has a derivative of 0. So the derivative of the second factor is just 5. So now I have all 4 pieces I need for the derivative. I'm going to find the derivative of this function y. I'm just going to write y prime equals, and now I'm going to use the formula. First factor is 3x minus 4 because it's a binomial, and I'm going to multiply it by something. I'm going to put it in a parentheses. So first factor, 3x minus 4, times the derivative of the second factor, which is times 5. That's the first part of the product rule, and then I'm going to put a plus sign down. And then I'm going to put the second factor, which is 5x minus 8. Again, I'm going to put it in a parentheses because it's a binomial, and I'm going to multiply it by something. So I have first factor, 3x minus 4, derivative of the second factor, 5, plus second factor, 5x minus 8, times derivative of the first factor, which is 3. If there were common factors, I'd factor out the common factors, but there isn't, so now I'm just going to clear the parentheses and combine like terms. First parentheses, I'm going to multiply 3x times 5 and get 15x. I'm going to multiply minus 4 times 5 and get minus 20. Second factor, I'm going to multiply 5x times 3 and get plus 15x. I'm going to keep that plus sign there. Now I'm going to do minus 8 times 3 and get minus 24. Now I'm going to combine like terms, which are the 15x plus 15x and the minus 20 and minus 24. I'm going to combine those together. When you're adding with x's, only the coefficients change, the exponents don't. So 15x plus 15x is 30x. The numbers have the same sign, so I'm going to add the numbers and keep them negative and get minus 44. I'd probably write this as for my answer. If you cared to, there's a common factor of a 2 you could factor out. If you factor out a 2, you'd get that, and I think that's as much as it possibly can be simplified. So that's how I want us to do the derivatives in this section. If there's multiplication and both factors have a letter, then we can use the product rule to do the derivative. If I could just figure out what the first and the second factor are and the derivatives of each, I could just shove those into the formula. When we get to the end of the chapter and we start studying, reviewing for the test, the techniques that we learned in section 2.1 are legal techniques to use, meaning I could find the derivative without using the product rule. Anytime there's multiplication, there may be 2 ways to find the derivative if the multiplication is easy to get rid of. So I could solve number 2 without the product rule. And to do that, I'd have to make it so the product rule doesn't apply. The product rule applies if there's multiplication and both factors have an x. Here, there's multiplication and both factors have an x, so the way the problem's written, I would have to use the product rule. If I didn't want to use the product rule, I can get rid of the multiplication by foiling. I can do firsts are 3x times 5x, which is 15x squared. Outers are 3x times minus 8, which is minus 24x. Inners are minus 4 times 5x, which is minus 20x. And lasts are minus 4 times minus 8, which is minus 32. And if I rewrote this by combining like terms, I'd get the function y equals 15x squared. Combine the outers and the inners. Those numbers in front of the x's have the same sign, so I add them and keep them negative. So that middle term would be a minus 44x and then minus 32. If I look at this compared to either one of the answers, it's not the same because I haven't taken a derivative. I've just rewritten the problem so that I can avoid the product rule. The way the problem was written, it was multiplication and both factors have an x. If I don't get rid of the multiplication, I have to use the product rule to find the derivative. If I get rid of the multiplication, then I'm not done. I have to find the derivative. So now I'm going to find the derivative of this. The first piece, I wrote y prime because I'm finding the derivative. I'm going to multiply the exponent 2 by the coefficient 15, lower the exponent by 1, and the first piece is going to come out to have a 30x, technically 30x to the first, because when I lower the 2 to 1, you get 1. The middle piece is the first power term. In first power terms, the derivative is just the number in front of the x without the x, so the derivative of minus 44x is minus 44. The last piece is a number without a letter, so it has a derivative of 0. And if I do the derivative after clearing the parentheses, I'm going to get exactly the same derivative that I got when I used the product rule. They're not going to take me to different answers, and there isn't like a right or wrong way to do the problem. If it's easier for you, in some cases, to clear the parentheses and do the derivative term by term, then you can do that. Or if you like using the product rule, then you could use the product rule. There will be times where it's just not practical to get rid of the multiplication, that it would just be just way more work to get rid of the multiplication than I'd ever care to do, so that at some point you're not really going to be able to bypass the product rule. So for the first 14 problems, I'm just going to do them all using the product rule, but a lot of the first 14 problems could be solved without the product rule by getting rid of the multiplication, combining like terms, and just doing derivatives term by term like we did in section 2.1. So I'm just going to go through now the rest of the problems in this section, and hopefully you can pause the video and do your odd problem while I do the even problem. So when I go to do problem 4, you go to do problem 3, there's multiplication and both factors have an x. So in problem 4, I'm going to write down what the first factor is. The first factor is x minus 5. And I'm going to write down what the second factor is. The second factor is 3x squared plus 7. In order to use the product rule, there needs to be multiplication. Both factors need to have an x. There's multiplication. First factor has an x, second factor has an x. Perfect candidate for a product rule. Before I start writing down the answer, I'm going to write down the derivative of each. So the derivative of the first factor. The derivative of the first factor is so easy, maybe it's hard. The first term's an x to the first power term, and x to the first power terms have derivatives of just the number in front of the x. And there wasn't a number written in front of the x, so it's an implied 1. The derivative of x is just 1. The number, it's of x to the first power term, and the number in front of the parentheses is assumed to be, in front of the x is assumed to be 1. The derivative of minus 5, since it doesn't have a letter, has a derivative of 0. So the derivative of the first factor is 1. Now I'm going to march off and do the derivative of the second factor. First term, I'm going to find the derivative of 3x squared by multiplying the 2 by 3 and getting a 6, lowering the exponent from 2 to 1, so I get a 6x to the first. Don't need to write the exponent of 1. The derivative of 7 is a 0 because it doesn't have an x. So the derivative I'm going to get by using the first factor times the derivative of the second factor plus the second factor times the derivative of the first factor. So I'll just take the 4 pieces and put them in. So derivative equals first factor is x minus 5. I'm going to put it in a parentheses because I need to multiply it by something. Times the derivative of the second, which is 6x. So that's first factor x minus 5 times derivative of the second, and then plus second factor 3x squared plus 7. I'm going to put it in a parentheses because it's going to be multiplied by something. And then times derivative of the first factor, which is 1. I didn't put the 6x and a 1 in a parentheses because they're just monomials. I didn't need to have them in a parentheses. But if this 6x was like 6x plus 4 and it had a plus with it, I'd put it in a parentheses. Now I'm going to clear the parentheses and combine like terms. First, I'm going to multiply x times 6x. I'm just multiplying the x's and leaving the 6 and getting a 6x squared. And then minus 5 times 6x is minus 30x. And then the second piece, anything times 1 is itself, so 3x squared plus 7 times 1 is just 3x squared plus 7. So I'm going to go 3x squared times 1 and get 3x squared, and plus 7 times 1 and get plus 7. And now I'm going to combine like terms. And the like terms I have is the 6x squared plus 3x squared, which is 9x squared. I think this is the answer. Just lately I've started teaching factoring by using the quadratic formula program. So let me see if this factors. So I'm going to go program quad a equals to 9, b equals to minus 30, c equals to 7. If I hit enter and I get i's or decimals, this is prime. If I get a fraction or integers, then it's not prime and it factors. So if I hit enter, this is prime if I see i's or decimals or both. And I see ugly decimals, so that's prime, so I know it doesn't factor. I don't need to do any factoring skills. And so that's the answer that I'd write down for problem 4. So you should go ahead and give problem 3 a chance. I'd use the product rule just to get comfortable using the product rule. Let me go through 5 with you as opposed to me doing 6, just because maybe it's a little more complicated. So I'm going to skip 6 and do 5. And as I go to do number 5, you might pause the video and try it yourself. So I look at number 5, there's multiplication. The first factor, factor is x squared plus 3x plus 2. The second factor is 3x minus 5. And it's multiplication. Both factors have an x. The product rule is perfect. I need the derivative of the first factor. First x squared term, I'm going to find its derivative. I'm going to bring the 2 out front in front of the x and make it a 2x. I'm going to lower the exponent from 2 to 1 and just write 2x without the exponent because the exponent's going to be implied. The middle term is an x to the first power term, and x to the first power term's derivative is just a number in front of the x without the x, so the derivative of 3x is 3. The last term is a number without a letter. It has a derivative of 0. So done with that derivative, move on to the next derivative. Now I'm going to do the derivative of the second factor. First piece is 3x. It's a first power term. The derivative is just a number in front of the x. Second piece is a number without a letter. Its derivative is 0. So the derivative of 3x minus 5 is just 3. So in number 5, because we're not doing number 6, I'm going to say the derivative is the first factor times the derivative of the second plus the second factor times the derivative of the first, using the prime symbol for derivative. So first factor, x squared plus 3x plus 2, putting it in a parentheses, times the derivative of the second, which is just 3, plus second factor, 3x minus 5, it's a binomial, I'm going to put it in a parentheses, times the derivative of the first factor, it's also a binomial, so I'm also going to put it in a parentheses. That's the derivative. Now I'm going to clear the parentheses, combine like terms, and see if it factors further. So first parentheses, I'm going to multiply x squared times 3 and get 3x squared. I'm going to multiply 3x times 3 and get plus 9x. I'm just clearing the parentheses. And plus 2 times 3 and get plus 6. Next parentheses, I'm going to FOIL. I'm going to go firsts are 3x times 2x, which is plus 6x squared. Outers are 3x times 3, which is plus 9x. Inners are minus 5 times 2x, which is minus 10x. Last are minus 5 times positive 3, which is minus 15. Now I'm going to look for like terms. 3x squared and 6x squared is one set of like terms I'm going to combine together. And those I'm going to combine to be 9x squared. The next set of like terms are plus 9x, and minus 10x. I'm going to go 9 plus 9 is 18. 18 minus 10 is 8. I'm going to write that as a plus 8x, because when you're adding or subtracting to combine like terms, the letter doesn't change, just the numbers in front of the letters change. And then the last pieces I need are plus 6 and minus 15. I think 6 minus 15 is minus 9. I think that's prime. Let me check real quickly. Program quad. A is 9, B is 8, C is negative 9. Decimals, so it's prime. If I got fractions or integers, then it would factor. But that's prime. So that's a perfect answer for number 5. All right, so maybe you could do problems 7, 9, and 11, maybe even 13 without me showing you. So if you want to just pause the video and just try 7, 9, 11, 13, check your answer. Don't even watch through the end of this video. That's completely fine. If you want me to, if you need me to, I'm going to do 8, 10, 12, and 14, maybe a little bit quicker than I'm doing them now, just so the video doesn't get out of control long. And that will take us to the end of this video. We'll start at 14 at the end of this video, and then the second part of section 2.2, I'll do the rule that has dividing. So a little quicker now as I do the problem 8. So So for problem 8, I'm going to write the first factor as 3t squared plus 5t. The second factor is 2t plus 1. First factor I can write without the parentheses, at least when I'm doing it down here. Eventually I might have to get that parentheses and put it back in. Derivative of the first factor, the derivative of 3t squared, I multiply the 2 times 3 and get a 6, lower the exponent by 1 and get a 6t to the first. The derivative of 5t, it's a first power term. The derivative of any first power term is just a number in front of the letter without the letter. So the derivative of 3t squared plus 5t is 6t plus 5. For the derivative of the second factor, the derivative of 2t, because it's a first power term, is just the number in front of the letter without the letter, which is just 2. Second term's a constant, so its derivative is 0. So for number 8, I'm going to do the derivative. First factor is 3t squared plus 5t, so I'm not writing down near as much now. That's first factor times the derivative of the second factor plus second factor times the derivative of the first. I'm going to put this in another parentheses. Anytime I have a binomial, it's safe to put it in a parentheses. So I did it perfectly. I found first factor, its derivative, second factor, its derivative. Then I did first factor times the derivative of the second factor plus second factor times the derivative of the first factor. Now I'm going to clear the parentheses, combine like terms, see if it factors. 3t squared times 2 to clear the first parentheses gives me a 6t squared. 5t times 2 to clear that parentheses gives me a 10t. Second parentheses I'm going to FOIL. First are 2t times 6t, which is 12t squared. Outers are 2t times 5, which is plus 10t. Inners are 1 times 6t, which is plus 6t. Lasts are 1 times 5, which is plus 5. Now I'm going to combine like terms. I'm going to add 6t squared and 12t squared by just adding the 6 and the 12. That gives me an 18, and when you're adding, the letter stays the same, so it's going to be an 18t squared. Then I'll combine 10t, 10t, and 6t. I'm going to go 10 plus 10 is 20, plus 6 is 26, so I get plus 26t. And then that plus 5 is just going to hang around. I think that's prime, but it's so easy to see now if it's prime or not. So program quad A equals to 18, B equals to 26, C equals to 5, decimals, it's prime. So that would be the perfect answer for number 8. And a little bit faster than I've been doing the other ones, and that's completely fine. For any of the problems between 1 and 14, if you want to, you can clear the parentheses and get the derivative without using the product rule. It's just that when we get into the next section, it's going to be almost impossible to do that. So I could have, for any of the problems between 1 and 14, cleared the parentheses like I did on problem 2 and just take the derivative term by term. But I'm going to pretend that I'm going to use the product rule just to get practiced. So I'm going to do number 10. First factor is 4x cubed. Second factor is 3x squared plus 7x minus 5. Derivative of the first, I'm just going to multiply the 3 by 4 and get 12, lower the exponent by 1 and get 12x squared. Then I'm going to do the derivative of the second. The derivative of 3x squared, I multiply the exponent and get an x to the first. Middle piece is the first power term. Its derivative is just a number in front of the x. Last piece is a constant. It has a derivative of 0. So for number 10, I'm going to say y prime equals first factor, 4x cubed. It doesn't need to be in a parentheses because it's not a binomial. So first factor times the derivative of the second needs to be in a parentheses because it's a binomial. So that's the first half of the product rule. First factor times the derivative of the second, and then plus Second factor, it's a trinomial, it needs to be in a parentheses. Times the derivative of the first factor, 12x squared. Clear the parentheses, combine like terms, see if it factors. So 4x cubed times 6x, I multiply the 4 and 6 and get 24. I add the exponents on the x's, I get an x cubed times an x to the first. I add the exponents and get an x to the fourth. Second piece, I multiply the 4 times 7 and get 28, and I leave the x cubed. Next parentheses, I'm going to multiply 3x squared times 12x squared. I multiply the 3 and 12 and get positive 36. I add the exponents on the x's and get an x to the fourth. Next multiplication, I multiply the 7 times the 12. I think I get 84. Yep. And I add the exponents on the x's. There's an x to the first times an x squared, so I get an x cubed. So it's going to be plus 84x cubed. And then lastly, minus 5 times 12x squared is going to be a minus 60x squared. So now I need to combine like terms. I'm going to combine the 24 and the 36x to the fourth by just adding 24 plus 36. Gives me 60. And when you're adding or subtracting, the exponents don't change. So that's going to be a 60x to the fourth. And then I'm going to do 28x cubed plus 84x cubed. Just add 28 plus 84 and get 112. Leave the x cubed and it's positive. And the last piece, the minus 60x squared, just tags along. I know each of the factors have an x. I have a common factor of an x squared that I should factor out. But in addition, all the numbers are even, so they all at least 2 goes into them. I think, well, let me just try to factor out a 2 and see what I get. If I factor out a 2, I divide all the numbers by 2. 60 divided by 2 is 30. If I took 2 x's away from 4 x's, I'm left with 2 x's. Middle piece, 112 divided by 2 is 56. Had 3 x's, I took 2 x's out, so I'm left with 1x. Last piece, I factored out a 2, so I divide by 2, and I took both x's out. This is not factored well enough, so I can still factor out another 2. I should have factored out a 4. Let me just go. I can either factor out another, let me just factor out another 2. So from this, and this, I can factor out a 2. And that 2 that I'm going to factor out, I'm going to multiply it by the 2x squared that's already there. And in front of my parentheses, I'm going to write a 4x squared after I factor out that second 2. I should have factored out 4 on the first step. From this, when I factor out a 2, I'm going to divide the 30 by 2 and get 15x squared. Divide the 56 by 2 and get 28x. And divide the 30 by 2 and get a minus 15. I think this is the best answer for number 10. Let me see if this is prime or not. So program quad, bam. I'm going to go 15, 28, minus 15. It's prime because of the decimal. So this is the best answer for number 10 that I could come up with. All right, just 2 more to deal with, and then we can move on to the next part of the video on the next rule. So problem 11 and 12, it's so easy to clear the multiplication. I probably wouldn't use the product rule. It seems overkill. But I'm going to use it anyways just because I can. Anytime there's multiplication and both factors have an x, you're allowed to use the product rule. Sometimes it's so easy to clear the multiplication that it doesn't make sense to use the product rule. So first factor, 7x squared for number 12. Second factor, 6x. Derivative of the first factor, I just multiply the 2 times 7 and get 14, lower the exponent and get a 14x to the first. The derivative of the second factor, since it's a first power term, it's just the number in front of the x, which is just going to be 6. So using the product rule for number 12, the derivative is going to be the first factor, 7x squared, times the derivative of the second factor, which is 6, no parentheses needed because there aren't any binomials, plus second factor, 6x, times the derivative of the first factor, 14x. Now I'm going to do the multiplication here. First multiplication, I just multiply the 6 and 7 and leave the x squared and get a 42x squared. Second multiplication, I multiply the 6 and 14 and get 84, and I multiply the x times x and get x squared. So now I have 42x squared plus 84x squared. I'm just going to add the 42 and the 84 and get 126 and leave the x squared alone. So my answer for problem 12 is going to be 126x squared. This is using the product rule. When we get later in the chapter, I probably wouldn't do this problem using the product rule because I can avoid anytime there's multiplication and both factors have an x. If it's easy to get rid of the multiplication, then I can avoid the product rule. So most of the problems I've just done, I don't really have to use the product rule. Because if I look at problem 12, I said there's multiplication and both factors have an x, so I'm allowed to use the product rule. But I'm also allowed to get rid of the multiplication and avoid the product rule. So for this problem, the multiplication is so easy to get rid of. I can get rid of the multiplication by just multiplying 7 times 6 and getting 42, adding the exponents on the letters and getting x cubed. I can rewrite the problem and then find the derivative without using the product rule. So if it's easy to clear the multiplication, like it is super easy to do here, then you can clear the multiplication and find the derivative just by the normal multiplying the exponent by the coefficient, lowering the exponent by 1. So if I was asked to do number 12 on a test, I wouldn't use the product rule because it took this many steps to get to the answer, whereas getting rid of the multiplication, then using the general power rule of multiplying the exponent by the coefficient and lowering the exponent by 1 will give me exactly the same answer with a lot less work. So it isn't always the case that you have to use the product rule. If there's multiplication and both factors have an x, you can use the product rule. If it's easy to get rid of the multiplication, then you can avoid the product rule. And that's kind of what I tried to show here. Same answer, just one was using the product rule, the others get rid of the multiplication first, then use the general power rule. So one more and we'll move on to the second part of the video. Let me do 13 just because it's a little bit messy. And quite honestly, I'm recording this video after a few years. I don't really remember what I have in my solutions manual in terms of factoring with the negative exponent. So I'm going to do problem 13, and I'm going to use the product rule. So I'm going to say first factor is 3x minus 3 times x to the x, 3 times x to the minus 4 power. My second factor is 5x squared plus 7. Derivative of the first, I'm going to go minus 4 times 3 is get minus 12. And then the trick is lowering the exponent by 1. Minus 4 minus 1 is what I need to do. Take the exponent of minus 4 and subtract 1. And when you do that, you're going to get a minus 5, because minus 4 minus 1, the numbers are both negative. You add the numbers and keep them negative. So the derivative of the first factor is 12x minus 5. The derivative of the second, the first piece, has a derivative of 10x, because you multiply the 2 times 5 and get 10. Lower the exponent by 1. Second piece is a no x term, so it has a derivative of 0. So in problem 13, the derivative equals the first factor, 3x to the minus 4, times the derivative of the second, which is 10x. I probably really didn't need a parentheses there, but it's fine, plus second factor, 5x squared plus 7, times the derivative of the first. Probably don't really need a parentheses there. It just feels right to put it in. Now I'm going to do the multiplication. First piece, I multiply the 3 and the 10 and get 30. And I add the exponents on the letters. The letters have exponents of -4 and +1, so I'm going to add the exponents, and when I add them, I'm going to actually subtract because those numbers have opposite signs. So I'm going to get -3 for the exponent. Second multiplication, I'm going to multiply 5 times -12 and get -60. And for the letters, I'm going to add the exponents. It's going to be 2 plus -5, because this exponent gets added to that exponent. Those numbers have opposite signs, and 2 minus 5 is going to be -3. Last multiplication, I multiply 7 times -12 and get -84. And I leave that x to the -5. Now I'm going to combine these terms because I have the same letter with the same exponent. And when you're doing that combination, only the numbers in front of the x's change, not the exponent itself. So I'm just going to go 30 minus 60 and get -30. And leave the x to the -3. And then the second piece, I'm just going to leave out -84x to the -5. Both terms are negative. I'm probably going to factor out a negative of the common factor, and I think 30 and 84 are both divisible by 2. So I'm going to factor out a -2 to get started. When I factor out a -2, I basically, in my head, divide the numbers that in front of the letters by -2. -30 divided by -2 is +15, so +15 is going to be the first number. And then -84 divided by -2, -84 divided by -2 is +42. So that's good, but probably could go further. We don't factor out negative exponents too much, and I wouldn't make you do it on a test, but I'll do it here. Both of the terms have an x, so there's a common factor of an x, and -5 is smaller. It'd be further left on the number line than -3, so I'm going to factor out an x to the -5 power. The second piece is easy, because if I factor out an x term identically, what's left is just the number in front of the x. I could have factored out a 3 here. Oh, here, I'll get to it in a second. The second piece, if I factor out a -5, I need to subtract what I factor out from the exponent. So I'm going to take this exponent minus the exponent that I factor out, and that's going to tell me what's going to be left for the x. So the exponent that I start with minus the exponent that I factor out is the exponent that's going to be left. And -3 minus -5, that double negative turns plus. The exponent really should be +2, because the exponent that I factor out, I subtract from the exponent that's there. This is, the exponent was there was -3. The exponent that I factor out that I subtract is a -5. I get a double negative, and that gives me an x squared. I should have, I didn't notice, there's a common factor of 3 here. Let me factor out a 3. From inside the parentheses. When I factor out a 3, I divide the 15 by 3 and get a 5. And I divide the 42 divided by 3 and get a 14. The 3 that I factor out, I should factor out, multiply it by the -2 and get a -6. This is way overkill, but it's correct. So that's a nice version of the derivative. It could even be simplified more. I can make the negative exponent positive. I'm not going to have you factor out negative exponents on the test, so this is a bit of overkill. So I'm going to put this video on YouTube now, and then I'll do a part 2, which it's fractions, and we'll kind of see where it goes. And maybe there's even a part 3 now that I look at the section. Sorry about that.